Good morning and happy Friday. I hope that you all have been having a great week so far. I've been having a lot of fun going through the book in between the streams, and I'm looking forward to finishing up the basics of the functions before we start actually doing real projects with this deep learning stuff. Is it Nikit.io or Nick Ito? Anyways, good morning and hello. So where we left off last time was we had decided to make a bunch of functions in their own folder here, and we also did this wrote those test driven. Nick, all right. And so we have a bunch of tests for these functions. And then where was this? This was single input, multiple output, gradient descent. Miguel, good morning. And so this neural network is a very super basic one that takes a single input right here, and it's going to be trained to go to this output. And today we're going to go to the sort of last combination, which is going to be multiple input, multiple output, .js. And when I say input and output, I'm also talking about gradient descent as the name of the algorithm that we're using. And that talks about if we were to graph the what we're doing with the weights and the inputs and the predictions and the changing of the weights, that's in the end what's happening. Earlier on, we did do hot cold, which is the other one, which I also don't think is used pretty much ever. But that being said, that's just the book. The book's saying it. So if you do use hot and cold in real life in a deep learning algorithm, let me know, and by tweeting at me. So this is in chapter 5 of the deep learning book. It was really interesting. The first project is actually at the end of chapter 5 and not its own chapter. But we'll get to that in a bit. I've been sort of starting to work on that on my the personal side in the Python. In Python. And it's super exciting. I actually had trouble sleeping last night because of how excited I am about actually doing something real with deep learning. But all right, so first things we need to do is start bringing in these functions. So const equals require, and it's the deep learning functions. And I'll just use the numbers they have here in, and I realize that I can use the numbers that they're using because the author made the deep learning code, like the solutions, available on GitHub, which is really nice. I like it when people do that. Also, I hate the fact that search is now in here. Yeah, this one. And so we're in chapter 5. So in the case anybody wants to go look at these, you could just search for find IAM Trask grokking deep learning, and we're on chapter 5. I am not going to go look at that right now. I did do this in Python, and now it's time to do it in JavaScript. But we're kind of sort of creating a library for later use as well. All right, so to begin with, we need to make our prediction. And I can sort of begin to code this out, but then if I need to, we'll add functions to the deep learning functions. So our predictions, it's multiple because it needs to be an array for the outputs. So we're gonna have 3 outputs. Actually, before I can do that, I need the inputs. So the inputs, what do we have here? Our inputs are going to be, I love how love how like they get fun with this. This is gonna be number of toes. What's interesting is that they have us doing multiple inputs. So this would be like multiple days worth of games. And then we're only going to choose the first one today, but we could imagine that we'd say, okay, train for 8.5, the result of whatever that means. And then the next day, something else happened, and we'll train at 9.5. And then the next time will be 9.9. The book hasn't had us do that at all, which I think is really interesting. Because the project is going to require us to do that. And so I don't know if that's the book forgot to put that in there, or if it's just going to sort of say, wait until this has been fully trained, move on to the next input, and then do it again until it's fully trained. I'm going to go ahead and just say that these are inputs. And so we know that it's the number of toes, which is 8.5. The win-loss record, which is 0.65, and the number of fans, which is 1.2 million. These are not from actual games. I don't think that there are people that only have 8.5 toes playing any professional sports, but how do I know? All right, so that's our inputs. We also need the proper outputs. So const the expected thinking maybe just like what really happened. And so this is what we're going to be trained towards. And so that is were the players hurt? Was it a win? And are the players sad? Again, I don't really know what this means in that conjunction. So I guess they're not sad because they won. But I also don't know why this wouldn't be a 0. But I'm not sort of like worried about that because the math is all that really matters. Okay, so we have the inputs and what really happened. We also need our weights. And this is where it gets really interesting because last time we had just an array of 3 weights because single input and then weights for each of the outputs. Now what we need is a weight for each input and a weight for each output, which means an array of arrays. And so this gets a little bit interesting. I'll just copy this in for right now. 0.1, 0.1, negative 0.3. I don't actually think that it matters what these weights are because the algorithm seems to be self-correcting. So as soon as it begins, I could just leave these all at 0 and they'd eventually find what they need to be. I suppose that if I'm really good, I could predict what the rates should be, and then that makes it for less training time. They have 0.0 here, but everything's a floating point number in JavaScript. 0, 0.3, 0.1. All right, here we have really? Don't do that to me. Okay. Here we have, when I save it, this is gonna, get a little bit screwed up. But what we have here is a matrix. So a matrix is really just an array of arrays, and then each column here is representing one of the inputs. So the first input is like the number of toes. That's the first input, so that's going to be the first weight all the way down, with on the side being each of the outputs. So this was how sad. So this would be predict how sad. Then this one is, did we win? Did we win? And were we, oh no, it's were we hurt. So player injured. Did we win? Players sad. So that's on the side here. And then on the top, we have the input. So this is going to be that input 1, input 2, input 3. So even though this is a 3 by 3, not all of the matrices are going to be like this. Some of the inputs are not going to, let's say we have like 5 inputs and only 2 outputs that we want to predict, then it would be 5 along this way and 2 down. So we do need to make sure our matrix math works appropriately in this way. Oh, that's hilarious. Okay, no comments. They don't make sense anymore. Also, I don't have any commas in here anymore. That's because I accidentally commented them out. All right, there we go. That should still work. And then finally, we need an alpha. That dog is being really loud. Give me 1 second. I'm going to shut the window fully. All right. Yeah, I think there's a squirrel outside tormenting the dog, and it was just yapping. Our alpha is going to limit the speed of learning for us. That way we don't accidentally learn straight over our target goal and then start doing that boomerang across where we're trying to get. And also the book says that the alpha is generally a factor of 10. So like 10, 1.1, 0.01. They're using 0.01. And I think that's all I need to sort of begin here. So we would have const my neural. So I need to first like create the neural network. Actually, my predictions equals neural network. I'm gonna pass it my inputs and my weights. And that's kind of it for that. Now, this won't work yet because I don't have this function. So let's create it. Neural network, we're going to take in our inputs and we're going to take in our weights. We need to now create just a single array because we only have 3 outputs. Therefore, our output needs to be essentially the same shape as this, an array of 3 things. I guess more like this. It wants to exactly just be this if I predicted it correctly. Which means I need to multiply all of these inputs. So all the inputs are going to be used in the calculation for each output. So all of these inputs multiplied by all of these weights. So this input by this weight, this input by this weight, this input by this weight, add them together, and then that becomes the first prediction. That's a vector multiplied by, I could do this a lot, but this is going to be vector matrix multiplication. I don't think we have that function, so let's add it. Scalar vector multiply, yeah, we don't have this. Let's go to our test. What is this going to be? Vector matrix multiply. It should return a single, I guess, a vector. It should return a vector. So our vector is going to be 1, 2, and 3. Two, 3, 4, 5, 6, 7, 8, 9. Const expected output. All right, so this is just going to be the three things. So we're going to take all of these and so 1. Nope, don't move. So 1 multiplied by 1 is 1 plus 2. So if I guess I could just leave this in here. So that's 1. 2 multiplied by 2 is 4 plus this 1 is going to be 5. 3 multiplied by 3 is 9 plus this. So 14 should be the first one. So I'm going to do this for the rest of them. (16 plus 7) 423. Katali, good morning. $50. All right, so this should be our expected output. All right, so we have the test running for this. So, I mean, hopefully I did the math correct. I should actually turn this on in case I'm doing anything wrong, and you can help me out here. Then we're going to create this function. We need to import it. All right, so what do we need to do here? We need our outputs, and to add them, well, we need our outputs. So const out, I guess it would be results. And that will be our array here, and we'll push the answers in. We need to loop through the matrix. We need to loop through the matrix, and for each row in matrix, so for each item in a matrix, we're going to multiply it. We're going to do a weighted sum. Do we not have a weighted sum here? Vector multiply. I don't think we do. Okay, so before I do this, I need a weighted sum. I've also been told that the official scientific or mathematical term for this is dot, which is interesting. The book did mention that this is called a dot, and then it's been mostly calling them weighted sums. Every once in a while calling them dots. So I guess I could just call this a dot. All right, so it should dot weighted sum two together. Const vector 1. We'll have this be 1, 2, and 3. Const vector 2. 4, 5, and 6. All right. This means this is the same thing that we were doing there. It's multiply and then sum together. So this should be actually just gonna be one of these. So it's the 1, 2, and 3, and the 4, 5, and 6. I think that's 32. We already figured that out. Which means, I guess now we just start assert. Okay, so then we'll bring in dot. All right, this is just going to be multiply one array and then sum them up. That sounds like a reduce to me. A reduce with the index, so we can access the second array. So this is really going to be a return vector. These do need to be the same length, so I can do this entire thing. If they're not the same length, throw an error. All right, let's reduce. Turn vector sum. Oh wait, do I have vector sum? I don't have a vector sum. And I do have vector multiply, don't I? Where it's just adding that together. So you're right, I could just do that, Katali. Okay, so I could be clever with this. I will vector multiply. That creates a new vector. So we're going to vector multiply vector 1 and vector 2. Then we're going to take that result and reduce it, which is going to give us the reducer. So I'll just call this the sum, and the next item. So I guess it's the number. And it's just going to be sum plus number. And I think this should work, but we'll find out because we have that test. So we do need to add in sum. All right, MPX, Mocha, test. Sum is not defined. Why did I call it sum? This is dot. Because I called that sum. Expected 32 to deeply equal an array of 32. Oh, yes. Okay. This needs to be an array. And then we're going to start with an empty array. Oh, I don't think, let's see. Vector multiply gives me an array of 3 things, and I want to reduce it to a single thing. Why is that not? Okay. Yeah, I know. It should return a number. Okay, what did I do wrong in my test? That's where it's wrong. Probably. Expected output, this is a number. A dot. Yes. Just this. That's the problem. So I had it correct. I just made a mistake in the test. That's always fun. And we're going to start with 0. All right, 7 passing, perfect. Yes, Miguel, a dot product should return a scalar. Now we can move back to this again. So we have our test. It's yelling at us because it doesn't exist. Back to you. Comment, uncomment. All right, so we have our results here. We want to loop through our matrix, and then for each of them, push in the result of a dot product between the row of the matrix, the current row of the matrix, and this vector. I could do a for each, but I could also do a map. I think a map would be a nice way to do a single line here. So return matrix.map. We're going to get a row, and we're going to return dot the vector and the row. Yep, Katali, I tied you. Also comma. 8 passing. All right, perfect. So this is how we're going to do our predictions here. So our neural network is going to take in the inputs, and what we need to do is we need to do the vector matrix multiply, and we're going to return vector matrix multiply with the inputs and the weights. and we have our initial predictions. All right, what's next? We need to get our errors. So the error is simply, well, okay, let's do the deltas first. The delta is simply the prediction minus what really happened to get the difference there. And I do have vector subtract here. And this returns a new vector. So that will get me the pure deltas. So const prediction deltas equals, let's grab vector subtract. And it's going to be our predictions and what really happened. All right, so we have our prediction deltas, which we'll use to recalculate the weights. We also need the error, like how far off were we? And that is, we can do this in one line here. We're going to go through the prediction deltas. Z's a good morning. Why not arrow functions that don't need explicit return? In here, or in here rather? You mean like why am I using normal functions as opposed to arrow functions? Or I guess I'm not really completely sure what your question is. So let's calculate the errors here. So const prediction errors, and did I do it again? I did it again. All right. Oh, I really haven't gotten into the idea of using arrow functions at like sort of like the base of the project. I had a calculate error function. Did I create that? Calculate errors. This takes two vectors and just, okay, well, that's what it is. Easy. Calculate errors. It's like I already did the work for myself. And this is going to be, is it just vector 1 and vector 2? It is. I subtract first and then map. So predictions, what really happened. All right, so that will give me my errors. Thank you, Katali. What am I developing here? I am going through exercises because I'm learning deep learning. And so I am making an example, multiple input, multiple output, gradient descent neural network, which is a lot of sort of mumbo jumbo for just basic functions that are doing math on projects. And most of it is just simple multiplication and division. So that's what I'm doing. Later on, I'm going to use what I learn here to actually do deep learning for real things, or at least real fun things. Okay, so we have our prediction errors. The next thing is I need to get weighted prediction deltas. And that will be used to change the the weights. So do I have the weights? How do I get that anyways? It's take the prediction deltas and multiply it by the inputs. So our predictions is an array like this. Our inputs is an array like this. So this input multiplied by this. Except that would only be true if we're creating a single vector. Our prediction delta, our weighted prediction deltas needs to be a matrix. It needs to have the same shape and size as our weights because we're going to subtract them together. So you recommend, I've used TypeScript normally. Just setting it up is like, but yeah, I've used TypeScript at work, and it's really good. So yes, I do understand, and maybe. Multiplies two vectors and returns a matrix. I think, well, I need to create the same shape, right? Which is, and this is the thing that always, I actually wrote this in a notebook. I have no idea if you're going to be able to see this because it's relatively light handwriting. I do want to get I don't have the cable to hook up my Wacom tablet, and I don't have do I have a whiteboard? I don't have a good setup for that. But I basically did the math for this. Let me make that large. It's not really focusing on it, is it? But okay, the idea here is that I'm going to loop through downwards. Yeah, I'm going to loop through downwards, and then along the sides, I'm going to say, okay, the first vector of I for the first one. Yeah, so two nested for loops. Yes, definitely. Is going to be multiplied. So it's going to be we have essentially this, two vectors. And then to turn it into something that looks like this. So this times this is top left. This times this is top middle. This times this is top right. And then so on to create the vector. The matrix. What do they call this? They call this an outer prod. What's the official name for this for this? Cause like outer product? If you know what this is called, I would love to know that. Essentially, it's like turn two vectors into matrix, which seems like not the right words. All right, so outer product, is that correct? So outer product. Turn two vectors into a matrix. All right, that's it. Actually, you know what? I don't need this here. It's going to be it here. It should turn two vectors into a matrix. All right, const my vector 1. We're gonna do 1, 2, and 3. Okay, so we're going to start with 1 times 4. So it's just multiplied. I'm not doing anything else. It's just, yeah, just the multiplication. It is called outer product. Side note, the dot product is also known as the inner product. Oh, okay. Should dot weighted sum inner product. That's really good to know. I like that. Also, I just screwed up my formatting. Thank you, Miguel and Katali. All right, so this is going to be a 4, 5, 6, 8, 10, 12, 12, 15, 18. This is one of my favorite things about doing test-driven development like this, is because I can use very simple examples, do the math myself, and verify that these algorithms are correct. So that way I don't run into, if you remember earlier in a week when I was writing them without the test-driven development, and our algorithm just sort of counted down infinitely. All right, so assert deep equal outer product vector 1, vector 2 is equal to the expected output. All right. Wait a second. I just got a nice, fun flash over my head, so I'm going to take a micro break and go walk and maybe grab a really quick snack. Fun after effects of that concussion I got earlier in the year. I'll be right back. All right, I'm back. I went and laid down on my bed for like a minute or two. It's a very interesting sensation, and it's very hard for me to describe what it is. It feels like a sudden drop in blood pressure, so you get this like weird feeling just all across the head, like a physical sensation. But I've learned to never ignore those because that can result in not good things. Katali, you shared your implementation. Awesome. I'll take a look at that a little bit later, maybe after I do this. Does it occur very often? No, a lot less often now. It was occurring a lot during right after the concussion. Basically, I guess what's the best way? Basically, anytime that I was like really concentrating super hard on a logical problem, it would happen. And if I didn't do anything about it, it would result in a headache afterwards. And I think it was something like either a blood sugar or an oxygen or something else happening to my brain. So just sort of slowing down. I think I just sort of got a little bit too into this, and that was like too much energy into my brain. I don't know. It's a very interesting. I don't know exactly what causes it. But laying down does equalize the pressure across my body, so that helps. Water also helps too. Food helps, like all the things. So what that means is I should slow down. is what it really means. All right. What was I doing? I forgot. Outer product. I am fine. I am better now. Thank you, Katali. I've learned to take care of myself, so I don't do things that are like for example, just going and taking a break immediately instead of powering through it, which is never a good idea. All right, so if we remember our outer product, these don't need to be the same size because we're not always going to be creating a square matrix, if that makes sense. We're going to do exactly what we said, nested loops, and as often as much as I would like to be able to do, actually, can I do? I might be able to be a little bit, tiny bit clever with this. So we're going to be const our matrix. Oh right, I'm kind of wondering, can I like create stuff and do that? Can I create stuff and do that? That's an excellent description here. JD Hirsch, good morning. I'm creating functions for my own deep learning neural network. So that's what I'm working on. Do I want to create a zeros matrix? Probably. That's probably the first step here. So I can create a function that generates our matrix, and then we'll go through that and update everything. So that's back to here again. Use the array constructor. Ooh, I haven't used the array constructor in forever. MDN array. Wait, do you have the constructor? New array, element 0, element 1. Oh yeah, I know you gave it to me. I'm trying to I want to figure it out on my own though. So I'm planning on looking at yours after I figure out mine. If the only argument passed to the array constructor is an integer, this returns a new JavaScript array with its length property set to that number. Ooh. So what you're saying is, is it new array like 5? Okay, so if I do position 3, undefined. Okay, so that works. So I'd want to, okay, so I could do that. I think I want to describe create matrix. It should create a matrix with I guess I'll just say should create a matrix. So our width is going to be, let's say 5. Is going to be 3. And our expected output. All right, so this is going to be, I think they're just undefined, right? So was that what I got? Is just undefined? Yeah. I wonder if this would work. And this is width 5, so I need 5 of these. And then height. So correct me if I'm wrong, but this is what it's going to look like. Yeah. And then we're going to assert. We're going to have our width and our height. And we're going to get our expected output. Create matrix. All right, so what do we need here? We need the matrix we're going to be creating, and then we're going to loop through. We're going to loop through the height times to create the empty ends. So that's const matrix empty array, not inside. For let, I don't really care about this, do I? It's just a count. So count 0, count is less than height. Is that count? This will create the rows, and now we need the columns, which will be our new array trick. So we'll say matrix dot push. This is going to be a new array of size width. And then we'll return. All right, let's see if we did it. Yes, should create a matrix. Perfect. Back to our outer product. All right, so outer product. We're going to create a matrix first. And we need to create this as the size. The inputs are to the right, so the inputs are the width, and the outputs are the height. And so I believe I have as the inputs are going to be I think I could do this. These are the inputs essentially. How am I going to use this? Oh, I haven't started using this. To get the weighted prediction deltas, I'm going to take the predictions and multiply it by the inputs. So I guess I'm thinking of predictions first. Does it even matter? Oh, no, it does matter, the order here. Or am I overthinking this? I should do the inputs first and then the predictions. So it's going to be vector 1. So if I do inputs first, inputs is going to be multiplied by everything else to go the width. So we're going to create matrix. We need the width. That's going to be the vector 1 dot length and a vector 2 dot length. I think that's how I'm creating this. I don't think I need to do anything else crazy. Then we need to get the various indexes for the matrix and then do that multiplication across the board. So for let, this is going to be the, do I even care about the first matrix? I almost feel like just vector 1 index. I'm going to now loop through the first vector, which is going to be going down. Wait, is that right? This is width, this is height. I need to do this to the vector 2 index. Vector 2 index first. You know, this is not helpful. I think I want to call this is going to be the height. The matrix height. And it's going to be the vector 2 dot length. Okay, so this is my outer loop. My inner loop is going to be over vector 1. So matrix width index. All right. We now have everything we need to build our matrix out and fill it out. So it's going to start with matrix of position, matrix height index, sub positions, that's on the up and down, then the width, matrix width index, and we're going to set this equal to vector our input. So I think it's vector 1. Am I going through, the input is the left one, that one multiplied by the first one, by the second one, by the third one, and then move forward again? So I think it's going to be vector 1. Let me relook at this. Okay, so vector, my input, where's that? I think I'm right, but I may be completely wrong. That's why I do testing. So vector 1, this is going to be the matrix. Thanks. All right. This is going to be our matrix height index. So it is. Okay. Matrix height index times vector 2 of matrix width index. If I somehow got it backwards or something, then our tests will fail. And then we'll return the matrix as soon as we're done. Why are you upset? Retrun. Ooh, that's a very interesting auto formatting for this. Not sure I like it. Ten passing. All right, first try. It took a little bit of time for me to get there. But we're now going to do that calculation for here. So const weighted prediction deltas. I don't really know what if this is supposed to have a different name for it. The book always just calls this weighted deltas, and we're gonna call outer product. We're gonna have our inputs and our predictions. No, our prediction deltas. Now that we have these, we need to update our weights. So we're going to take this matrix and subtract it from this matrix, while at the same time multiplying this matrix by the alpha. I do have an idea that I don't necessarily want to like pass the alpha in. If I did a scalar matrix multiplication, then I would be able to create the limited, like the scaled, it would be the scaled weighted prediction deltas first, and then I can just do a straight subtraction between the weights and the scaled weighted prediction deltas. So let's do that, which means I need, what do we have here? I need scalar matrix multiplication, which we don't have. So let's create it. I don't know if this is a real thing. I'm guessing that this is actual real math I'm doing and not another lie like some of the other ones I've done. Okay, so our scalar, I'm going to say is 10. Yeah, it's real math. Also, your name has no vowels. So if I was to attempt to pronounce this, it would probably be anyways, good morning. Close enough? Awesome. I will probably not try to say your name again. Our expected output here, 10, 20, 30. Oh, I forgot the deep equal. All right. Let's go make our scalar matrix multiply. I am misspelling things like crazy today. All right, well, we need to loop through our matrix and update it. Because the matrix is passed by reference and it just has references inside of it, I wonder if I could, for each through the matrix, and then map through, no, I mean, I could. I don't think it's that good of an idea. I think it's probably better for me to do the double for loops again. Oh, you're right. Oh, wait, no. Matrix map vector, scalar vector multiply scalar vector. I lose the shape of the matrix though, because matrix map doesn't change what's inside of it. It returns a new one. I could matrix reduce and then return the new vector that's from scalar vector multiply. That's what I could do. So return matrix dot reduce. We're going to get the I don't even know if I really care about the previous value here. Oh no, yes, I definitely do, because this is the full matrix then. What am I setting this to be initially? This is really interesting. Yes, you're. Oh, I'm gonna just this will start with a simple array. So it'll be a new matrix. And then the other thing will be the current vector. We're going to return this scalar multiplied by this vector. So it's going to be scalar vector multiply the scalar, the vector. And the beginning is going to be just an empty array. I also have to then take this new matrix. Okay, I can't single line this. Not easily. I'm not going to be that clever. So we're going to new matrix push the result of a scalar vector multiply. So that will become the new row. And then we'll return the new matrix. I think that'll work. Yes. Because it returns a vector with the same proportions, yes, that will definitely work. And I just had to do this with 2 lines here because I need to push it in, and the return result of a new matrix push is not the array, but the new length of the array, which would not necessarily be what we want it to be. So now that we have that, we come back to here, and we're going to get, all right, what is this called? This is the scaled I need that's definitely not it. It was the scalar matrix multiply. Our scalar is going to be our alpha, and our matrix is going to be the weighted prediction deltas. All right, now we have our scaled weighted prediction deltas. We need to subtract the weights from the, the scaled weighted prediction deltas. I don't think we have that, do we? We need a matrix subtract. So let us create it. I guess I can create the what is this? The signature first. Let's make this one bigger so that way will work with positive numbers. So we'll start with 10. And our expected output is, because I'm going to do first minus the second. So 10 minus 1 is 9. We should be able to run this and, oh, interesting. Oh, deep equal. There you go. I was going to say, that was not the right error message that I was expecting. Okay, so let's go actually fill out this function. This is going to be simply taking each position of the matrix and subtracting it from before. And I think, did we create a scale? Any other subtract? We do have vector subtract, and this returns a new vector. So I can just use this, and it's going to be the exact same thing that we did with vector multiply. So we're going to return we'll do matrix 1. We just have to remember that that's what we're doing. All right, so we do need to push in, so new matrix, push the result of vector subtract, and we're going to take the matrix 1 vector and the matrix. Oh, wait, I need the index. That'll work. Matrix 2 index. So the same sort of like location there. Once I push that in, then we're going to return the new, return new matrix. And we're going to start with an empty array. What am I missing? Comma expected. I failed to close this. There we go. Let's see if this works. Yes. I'm doing pretty good at writing these first try. Return matrix A dot map. Oh, okay. You did using maps. Vector index. Yeah, I think that would also work too. But I've got that's working, so I don't need to push to a new array. Yeah, we could try that. Let's try this one. It's my alarm for getting close to the end of the stream, but it is also Friday, which means I get to work from home today, so I don't have to worry about the commute. So I have a few extra minutes. All right, so let's see. I want to. This is the way that I initially wrote it, which is a exact copy of that. Let's try this one. Where did return matrix 1 dot map, and then we're going to get the matrix 1 vector and the index. So I guess it doesn't matter. It's index for either. And what we're going to do is we're going to return vector subtract. So vector subtract, and it's going to be this matrix 1 vector and matrix 2 of index. Let's see if this works. Yeah, this works also. So the way this works, if we want to look over it, is this returns an array. And so we get the first item of the array, and then that just sort of enters that into it. So this is working. I do like this a lot more. So I am going to replace this. And let's do the exact same thing here. So we're going to return our matrix dot map. We're going to get the scalar. Actually, do I need the index at all? I think we don't. We're just going to get the matrix vector, and then we're going to return the what is it? Scalar vector multiply with the scalar and the vector. Matrix vector. Perfect. Tests are still passing. This is the best thing about tests, is you can do these type of refactors and just be confident that it's working the way we want it to work. Let's come back to here. So this last thing that we need to do is const. We're going to replace our weights. So these weights need to be a let. How did I do that? Should not be possible to pick up the output. All right, so our weights are going to equal, right, I need to actually pull in the function. So what is this? This is going to be matrix subtract of our weights and the scaled weighted prediction deltas. And now our weights are updated. They've either increased or decreased depending upon whether or not we're going towards our what really happened. Miguel, gotta go. The heat is too overwhelming. Well, thank you for stopping by, and I hope that you have a great rest of your day. Zish, good morning. So I can print these out. So that's console.log. The predictions. We could inspect the weights if we really need to. So node, what is this? Multiple input, single output. Oh, vectors must have the same length. Do I really need that? At dot. So at the dot and deep learning functions, line 25. What I can do here is run the debug. Add configuration of just this program, I think. Wait, let me just try. Right, okay. So what is this? Line 25. I'm going to put a breakpoint here. Oh, line 11. You try to tell me. Why are you doing that, mouse? Line 11 here. So return vector matrix multiply inputs and my weights is the vector matrix multiplication. Yeah. So, oh, right. They don't need to be the same length, do they? That's, well, in this case, they should be, though. So I don't know why it tripped. But okay, so return vector matrix multiply our inputs and our weights. Also, I don't know why your line didn't work. Did it go somewhere else? No, the line thing just didn't hit. I'm a little bit sad. Let me try resetting that up. All right. Vector matrix multiplication. Then we're going to dot each row with the vector and the row of the matrix. Well, yeah, so I know that's the error. Collage? Hello. If vector 1.length is not equal to vector 2.length, I guess I could paste that into the vector matrix multiply. It is hitting this right here, is this error. This is where it's vector 1.length is not equal to vector 2.length. I think, because that's the interesting part. But yeah, I could add this error into here too. So what is this? If vector.length does not exactly equal to matrix.length, return. I guess it's not a return. It's throw. Throw new error vector and matrix must have the same length. And we can try running this again. Terminal. And we get, okay. So it's at the dot. So it passes here, and it's at the dot. Klaj, good morning. Hello. What are we up to? I am creating a sort of a homegrown deep learning neural network using the Grokking deep learning book as my learning source. So I want to, where is that? I want to essentially, right when we start our neural network, pause here. Well, actually, we know it survived. What happened? It survived this. It got through vector matrix multiply. So it got past this line. It went into here, and we didn't get what we expected to. So I'm going to pause. I'm going to breakpoint here. We're going to launch the program, and we're going to pause it. We don't need you anymore. So here is, we now have a vector and a row. Well, actually, we haven't got it yet. Let's step in. Ooh, it hasn't finished. Oh, that's interesting. It's just started running into it. So we have a row. Here's our array of 3 items. So that's our that is a vector. And do we also have vector? Which is also an array of 3 items. So we're going to call here. So let's step in again. So our vector 1 is a length of 3, and vector 2 is a length of 3. Okay, so it must be one of the next ones. So we return that. We go through. What is this? This is step F11. Why is array 1? Why is row now length of 1? It's just 0. Ooh. That's why we're going to get the error. What does matrix look like? Matrix is not available. Why isn't that available? Check where you defined your matrix. I defined my matrix out in the beginning, right? So our weights, right? Why are you parentheses in here? Oh, that's odd. Thank you, Katali. The auto formatter, apparently, like when I had tried to do those comments in there, I had commented out the commas, and so it did some crazy stuff to my code. But here are my predictions. Now, this won't really help us unless we can tell, like, are we moving in a correct direction? So what I want to do is we're going to loop through this. count equals 0. Count is less than, let's do 5 times. So the far left one should be moving towards 0.1. And that is definitely not happening. So we start at 0.55, we go to 0.1, and then we go to 0.03, and we're keeping on going down. So we've got the infinite down problem. Let's see about the others. We've got going towards 1. So that's 0.9. This is also going down forever. So it started low and is going down. And the third one is going to 0.1. It starts at 0.96 and is going down. But I can't believe it's not just going to like keep on going down forever. So this is not exactly what I wanted. I have a bug in here somewhere that's not doing exactly what I wanted it to do. So looking at the book, what was I supposed to have done? So starting with our neural network, it's doing this vector matrix multiply, which is that dot, the weighted sum for each line. So the vector matrix multiply with my inputs, that is a vector by each of the lines and awaits. Now the other potential problem is, have I done the math wrong in the tests? Like, did I set those up incorrectly? You've also had this problem, Kotali, and checking the outer product function solved it. Also, Zish, yes, interesting to debug now. Yes, definitely. We'll get there. We'll get there, Kotali. I'm betting you're correct, because I had this exact same problem with like in Python when I was doing it, and it was because I rushed myself, and then I wrote it down, and then I got it working. All right, what was right? Because the outer prod was the one where I wasn't sure if I was doing it right. Wasn't that outer product? So we have that. Then we're gonna get these prediction deltas. The prediction deltas is simply to subtract the prediction from what really happened. So we're doing that here. We weight that by taking our predicted delta and multiplying it by the inputs. And that's this outer product. And that's the really dangerous one. I most likely reversed the vectors. And the other question is, now the tests are passing. I wonder, if the tests are passing, then the math is correct, and maybe these need to be reversed. So if I do prediction deltas first and the input second, I wonder if that will change it. Look at this. It goes down and it hasn't passed 0.1. This is going up and it's sort of stopping. So that was it. I reversed the input of my outer product, and that's all I needed to do. So thank you, Kotali. That was super helpful in debugging. Also pretty quick. Now that we have this, we need to write a function to determine if we're done. So So function reached, is it like reached error or are we done? I'm not really. Basically our prediction errors is also a is also this what is it called? Is an array, a vector of the same size. I want to have here const error threshold 1, 2, 3, 4, 5. We'll just say that it's an arbitrary number. I don't know if there's like a best choice for this. I want to, for each of these, check to see if the error, so these are the predictions. Let me show you the error, prediction errors. Unexpected token const. Oh, yeah, that's because of you. So here's these prediction errors. You can see that they're really small numbers, incredibly small numbers. And that's because we're taking the errors and we're multiplying by themselves, so the power of them. The prediction errors we're going to use to determine if we've successfully trained the network for this series of inputs. So right now, like if it's within this, we can call this done. I can even add like 5 more. I don't know what my limit in floating point numbers is for this. But my idea is that function reached, grab the code. Oh yeah, well, I could just do that too. I can cheat and use the code I already wrote. Where was that? Single input, multiple output. Here is this, still learning errors. I'm reducing. So I need my errors. So I'm actually gonna just borrow you. So I'm just gonna call this still learning. And okay, so we're gonna get number learning equals errors, which means I need to pull in the errors. We're gonna reduce through this, still learning the error. If the error is greater than it, so I need the error threshold. Return still counting +1. And then we're going to start with 0. So this is the count. So this is really like the count learning. And I'm going to return the count learning is greater than 0. So right here, I'm going to make this prediction still. And we're going to say if still learning, we need the errors. So that's the prediction errors. And we need the error threshold. So if this, we're going to break it. Yeah, well, I guess what I could do is return this is greater than 0. That's what I want to do. And we then need this to not be a for loop anymore. You are now going to be a while true. So just infinitely loop until we've successfully trained and then stop. It ran once. So this is wrong. Wait, is this return? This needs to be equal. I could also use a double negation. That sounds terrible though. Oh, still learning. Did I? If still learning. If not still learning. That's what I want. If I'm not still learning. And we can see here's how long it took before it reached our error threshold. I can keep on adding zeros to this until eventually JavaScript tells me that I'm a terrible person, and it will train until it's like closer to where we want to be. Usually we define a number of iterations to not get stuck in a loop. Oh, also, okay. So to say like, oh, we're going to go like a maximum amount. So what would that be? Const max iterations. And we can loop through this too. This needs to be an if, let. So max iterations equals max iterations plus 1. And then down here, so if either we're not still learning or max iterations actually max iterations, I want to set this to like 100. And then we'll have, this will be a const, that iteration count equals 0. I guess I could make this a for loop. I guess that makes sense. Is instead of like this entire thing, we'll just do a for loop. For let count equals 0. Count is less than our max iterations. Let's say like 1,000. Then I don't need any of this crap in here. And I don't need you. So we're just going to go until we break. The first negation converts it to a Boolean, and the second returns it to the... Yeah, I know. I know I could do that. I just hate doing that. The double bang, because I miss it so often when I'm reading through the code later. And so that causes me to sort of miss that. Zish, yes, I know I could do the plus plus. I just got into the habit of not doing plus plus, and it's for the same reason as the bang bang. I've noticed that I can miss it sometimes when I'm reading through the code. And it makes it, it's a personal preference. So running through this. And then this has trained. Now, from what I understand, if I want to actually truly go through this, I would have a series of inputs, not just this one here. Of course, and there's plus equals. I don't know why, I just didn't get too much into the habit of plus equals. I think it was a Lua thing that sort of like caused me to to go like start going into that more often. And that's just something that happened. Yeah, I don't know why. All right, let's from what I understand, if I had like multiple inputs ready to go, I could run through this, train it on this first set of inputs, and then I say, great, we're good for like the first day of games. Now let's move on to the second day of games. Change the inputs, but I keep the weights. So I change the inputs, I change what really happened, keep the weights, alpha, the error threshold, everything else, and restart it over again. Yeah, it's a readability reasons, although that's only for my personal code. Like at work, I just follow whatever the team is choosing to do. So it's impossible. It's more of my own personal quirks. And then do that again, and then again, and again. And because we're playing with statistics here, I have no idea how many we need to like make the bot super accurate. This next, where is it? Oh, I went way back. The next project is at the end of chapter 5, and it's going to be an actual real thing. And this project doesn't actually give much direction for what to do for it, but it's taking in the MNIST data and writing a neural network to predict handwriting for numbers. Yes, the MNIST dataset, which I think is pretty cool. And I sort of double checked yesterday, and there is a NPM module I can pull down that has the MNIST dataset available for us too. I want to stop when it converges. The error doesn't change too much. Right. So that would be my error threshold. I don't know. Why is that my error threshold, or do I want to keep track of the previous error and like have how much it changes there? The book hasn't really gone into like choosing when to stop. Choosing when to stop very much. So I'm not exactly sure. Yes, keep track of it. So I want to keep track of like the previous error threshold. This would not be an error threshold. This would be like an error change threshold. And then that would be it. Can I send the module? I will share it with you. Obviously, I'll also be doing this on stream. But if you're there, let's do npm mnist. This is the data set. And I sort of played around with it. It's going to be exactly what it says it does. It grabs and allows you to grab the number of training data and sort of mixes. I mean, this is setting like, so you get the test set and the training set. Oh, you're trying to find something to prepare the data. Oh yeah, if you just go to the MNIST and website and download it, it's terrible. Like by terrible, I mean it's just in the raw format, and you have to do a lot of data manipulation to get it into arrays. This does it for us, and we're just going to get our numbers. What I don't like about here is that this doesn't say which one this is to verify, like, is this beginning with 0 or ending with 0? I think this is beginning with 0. But yeah, that's it's just npm mnist. All right. Well, this has been a super long stream. It's also been good that we finally got the multiple. That's a 6. Awesome. Also great that we got our multiple input, multiple output, gradient descent neural network up and running. We'll now be able to use these functions next time to create the neural network to go through the MNIST dataset and predict some number handwriting. And as soon as we do that, we're going to move on to the project. I'm sort of going to diverge from the book a little bit because I only have 2 weeks until the conference talk. And this all is in preparation for that, where I am going to attempt to make a neural network that plays a game of Pong. Or at least that's my plan so far. So with that being said, let me push up all these changes. I don't need a launch JSON, so I want to add in wait, I already have a get ignore. What is this called? Launch jet JSON. Yes, okay. All right, gradient, descent, multiple input, multiple output, neural network. All right, and pushed on up. I'll need to learn reinforced learning. Oh, is that what I need for this? Is that what I need for this? The number thing is reinforced learning. Yeah, if it's a free book and it's not a license, I kept on wanting to say validation, but that's like not right. If it's not illegal for you to send it to me, then yeah, send me a link to the book. And hello, Andre Lamas, the AI. All right, well, I think I'm done. I'm tired. I need to get sort of like rest my brain for work today. So I will share with you all the code that I sent up. Today was gradient descent, multiple input, multiple output, a neural network. So that's really just a bunch of matrix math is what that was. But I am also super over time for the stream, so I am going to shut it down. I'm going to work on this, all this this weekend, and try to get this working in Python. And then on Monday morning is the next scheduled stream for learning deep learning, and that should be 6:45 a.m. Oh, backtracking and stuff. You don't like that one? SVMS. I don't know what SVMS is. On Sunday morning, I am doing a stream with Kale where we're making a stream schedule page together. And that's in PHP, Laravel, and Vue.js. So that's at 7 a.m. in the morning on Sunday morning. So with that being said, I am going to call it for the morning. And let me switch over to the end screen. And I'll see you all next time. Thank you so much for stopping by, and have a great rest of your day.